Hi everyone, welcome to another episode of Rocking DFT. We have discussed, the BIST architecture in our last video, okay? And we have discussed that how can we classify BIST into different architectures based on the hardware, based on the clocking schemes, okay? We discussed a unique problem associated with the STUMPS architecture, which is called the test per scan architecture. And that unique problem was structural dependency, okay? So if you can see this figure on the screen, if you are having an LFSR, okay, and you are propagating, the values to the scan chains from LFSR, but due to the shift feature of an LFSR, you can see the bits which are in the diagonal, diagonally the bits which are there from one chain to another, okay, which are being marked by the red arrows. So these bits in the diagonal lines are all same. So because of this feature, what's going to happen? If suppose, the bits which are in the diagonal lines from one scan chain to another one are having the same values. So if suppose you are having if you are having an AND gate, okay, which are actually there were two inputs of AND gates are carrying the two bits of these two scan chains which are diagonal in nature. So what's going to happen? The stacked fall is going to become untestable. Okay, so this is a basic and important issue what we are having with the STUMPS architecture. Okay, so this is called the structural dependency. Okay, and how we are going to resolve this problem? So this problem can be resolved by introducing a hardware that is called a phase shifter. So this problem can be solved by inserting a phase shifter between the LFSR or between the LFSR and the CUT or the DUT. This is called design under test. Okay. So phase shifter, what is phase shifter? So phase shifter is serial to parallel converter, and this is used to shift the phase of the scan chains with respect to the reference scan chain. For example, the different scan chains would be shifted. Okay, with reference to the main scan chain by different test cycles. Okay, and the main props what we are going to gain, or what is the main gain when we are going to introduce the phase shifter, that it is going to remove the structural dependency. So the main problem is it's very difficult whether, so the question arises whether it's really very difficult to implement the phase shifter. Not at all. Phase shifter can be easily implemented by a XOR network, XOR network. Okay. So if you understand how the LFSR work, okay. So LFSR is having very nice and good features or the characteristics. And the one of the main feature of LFSR is that, the mean sequencing problem of the LFSR can actually help us to implement the phase shifter. So there is something called the mean sequencing, okay, property of an LFSR. So if you are having an M sequence of the phase shifter one of one chain, M sequence of the phase shifter of the second scan chain, then it is going to create M sequence of the third scan chain. So for example, if you are doing the XORing of the two LFSR outputs from two different chains, then it will create another M sequence with the phase shifted or not from the different chains. If you are doing the XOR, if you are XORing of two LFSR outputs, it is going to create M sequence with the phase shifted. So this is the property which we are going to exploit when we are going to design the LFSR. So we can design the phase shifter with the XOR network. There is one particular equation. If you want to design the phase shifter by on your own, so you need to find it out what is kind of a characteristic polynomial what you are using for an LFSR. And then this equation, if you are going to use, then it will help us out to design the phase shifter, like where are the tap points from the different flip-flops which you are going to get, so that you can introduce the XOR gates over there, and then the whole LFSR, the whole phase shifter can be designed. So this is that equation. This equation is pretty simple. It is called P is equal to BT raised to the power S. So where is the P is the tap points of the different flops, and B is kind of a selection vector, and S is the number of the cycles. Okay, so anybody can easily design the phase shifter by if he knows, okay, what are the different tap points when he needs to know, okay, what are the different tap points of the different flops which are the part of the LFSR, which are actually propagating the values in the LFSR. You need to know about the selection vector, and you need to know like what is the companion matrix, and how many number of cycles with which you just want to shift from one for the you want to shift the phase from with respect to the reference scan chain. Okay, so this is the one equation which we are going to exploit to design the phase shifter. Now, what are the advantages of the phase shifter? So there are the several advantages of the phase shifter. It can reduce the structural dependency, and it will also increase the randomness. The main problem what we were struggling before, if your pattern is, if your fault model, whatever you are using, it's not random, okay, in nature, then what's going to happen, the fault coverage will not be enhanced. So increasing the randomness is a very important factor. So when you are going to reduce the structural dependency, okay, in the STUMPS architecture, the randomness is going to increase. Okay, so this is a very important property or very important advantage when we are having a phase shifter. Second is the phase shifter. Designing a phase shifter is not a big problem. Okay, you can just introduce the XOR points. You can exploit the equation to know what kind of circuitry you want to design based on the characteristic polynomial of the LFSR which you are going to introduce. You need to know the companion matrix. You need to know the you need to know the selection vector. So those kind of input parameters you are aware, then you can easily find the tap points where the XOR gates are going to be introduced, and you can design the phase shifter. And so the area overhead is quite small, and you can support more scan chains than the LFSR degree. Okay, so it can actually create lots of internal scan chains when you are going to have more LF kind of networking in the phase shifter. So you would be getting more scan chains. So these are the three major advantages when we are going to have that phase shifter in our design. So this is so you can see the figures what I have introduced in this particular video. Just try to understand why phase shifter is required, how it's going to help us in reducing the structural dependency, and how it is going to increase the randomness of the pattern what we are going to use, and what kind of equation we need to use. So actually you can design this hardware in a pretty easy manner. Okay, so thanks a lot. This is a short video on the phase shifter. So next time I'll come back with another video on some other BIST related queries. Okay, thanks a lot. Enjoy yourself.